Already we are in part 2 of our gas laws where we actually talk about the ideal gas law. So, in the previous nato nga video, we talked about these four laws kung diin naghalin ng ideal gas law. And now we'll have some examples in the ideal gas law natin. So, let's move in. Oh, by the way, before we start with the examples, meron ko sang idugang nga information about sa aton nga universal gas constant. So, our universal gas constant is physically the constant of proportionality that relates the energy scale in physics to the temperature scale when a mole of particles at that stated temperature is being considered. Now, miyara kita sang formula nga ginagamit where R, or the gas constant, is equal to Na times K. Now, if you look at the back of your calculator, Na is constant, let's see here, for sure, that's constant 24. K is constant 25, kasunod niya lang na. And again, once again, ang aton nga R is constant 27. Now, Na stands for your Avogadro's constant. Avogadro's constant, and it states there that it is the proportionality factor that relates the number of constituent particles, whether that be a molecule, atom, or ion, in a sample with the amount of substance in that sample. Actually, Avogadro's constant is 6.022 times 10 to the 23 per mole. Whatever that is, it can be ions per mole, or atoms per mole, or molecules per mole. So, amo na siya. If you can't memorize it, you have the constant right there. Also, K is actually your Boltzmann's constant. Boltzmann's constant stands for 1.38 times 10 to the negative 23 joules per Kelvin. As you can see, guys, Boltzmann's constant is the average, or relates the average relative kinetic energy, that's why it's joules, of particles in a gas with the thermodynamic temperature of that gas. That's why it's Kelvin. So, amo na siya, guys, ng aton nga R. If you multiply these two constants, you get, going back dito sa kanina, you will get 8.314 joules per mole Kelvin. Okay? It's all because of this. Now, no need to memorize this, but at least you know where it came from, diba? Okay? And let's proceed to some simple examples. So, what is the temperature of 4 moles of a gas at a pressure of 5.6 atmospheres and a volume of 12 liters? So, again, ang given natin listahon ta. Okay, so here we have what is the temperature of 4 moles of gas. So, dapat listat ang given ta, no? Moles is 4, or moles is N equals 4 moles. And then ang pressure naton, that's 5.6 atmospheres. Ang volume naton, that is 12 liters. Okay, so ang ginapamangkot, what is the temperature? Now, observe, guys, ang aton nga mga given, ang units nila, moles, atmosphere, and liters. Now, kung mabalik kita sa aton equation, PV is equal to nRT. So, ang aton nakilangnanon, mabilin si T sa diri nga side sa equation. So, N and R will be transposed to this side. We are now left with PV over nR equals T. Okay. Now, P is 5.6 atmospheres. V is 12 liters. Okay? Ang aton nga N is ito, 4 moles. Now, ang ginapangita is temperature. So, gina-expect naton ang mabilin is Kelvin. So, dapat ang isulat naton diri nga R para sa value ni R is the value nga makapang-cancel sang atmosphere, liters, kag mole, no? So, kung gusto niyo mabalik kita sa aton nga original dito. Okay. So, liters, atmosphere, kag mole ang gusto naton hukson. So, ini siya na value sang R ang gamiton ta, si 0.082 liters per atmosphere per mole Kelvin. So, let's go back. Mhm. So 0.082 liters atmosphere per mole Kelvin. Okay. So with that, cancel si atoms kag si liters, ayos lang nga duwa. Cancel si moles kag ang mabilin manggid sa atom is just the Kelvin. So yay! Temperature. So grab your calculators, that's 5.6 times 12 divided by 4 times 0.082. And that should give you 204, 204.88 kelvins. Okay. Now, you may not be comfortable with kelvins because we are Filipinos. Mas familiar kita sa degree Celsius. So, what does it look like? A review. To convert degree Celsius to Kelvin, you just add 273, di ba? Now, if you want to convert Kelvin to degree Celsius, subtract kita to 73. Okay. With that, ang atong temperature is 204.88 minus 273. Minus 273. That is negative 68.12 degrees Celsius. Okay. It's not stated there kung ano nga temperature ang kilanglanon. So yeah, let's stick with Kelvin lang. Though curious lang kita sa ngagina mo. Oops. Okay. So that is our first example. Okay, how about a second example? Now, we have this, the pressure inside a 60-liter container. So, hindi ka makibot hindi ni siya pressure, 60 liters na mo. The volume ni siya. So, 60 liters. Having 3 moles, so 3 moles na, N na siya. Okay? At a temperature of 400K. So, temperature naton 400 Kelvin. So, what is the pressure? P. Question mark. Tawon-tang aton nga mga units ha. We have liters, moles, Kelvin, kung ano karon nagamiton ta for our gas constant. PV is equal to nRT. We want P to remain in this equation or in this side of the equation. So, si B transpose sa dalom. That's now P equals nRT over V. Okay. N is 3 moles. Okay. Ang R, ang pinakamayo nga gamiton natin sa R is still 0.082. Kaya nga, you have liters, you have atmospheres, and you have moles per Kelvin, or mole and Kelvin. And then temperature natin, that's 400 kelvins. This is all over 60 liters. With that, si mole makancel, si liters makancel, si Kelvin makancel. So, goods gid kay ang pressure, atmosphere man gid na ang iya nga unit. Okay. So, you have 3 times 0.082 times 400 divided by 60. And we are left with 1.64 atmospheres. Okay. So, wala man gid na strict kung ano ang unit. So, yeah, we can work with this answer. However, if ginapangita sa inyo instead of atmospheres is pascals, remind you guys, 1 atmosphere is equal to 101,325 pascals, no? So, ang himuon ta para i-convert ni siya into pascals is to matubala sa aton nga sugod-sugod gid sa unit conversion. So, atmosphere, since gusto siya i-cancel out, butang ta siya sa dalom. And then sa babaw si pascals, no? 101,325. And then cancel, hindi ko lang pag-i-touch niyo kay final answer nimo. So multiply kita. P now in pascals is 101,325 times 1.64. And that is 166,173 pascals or 173 or 173 kilopascals. So either of them will work. But yep, it's not being asked, so you can live with 1.64. Okay? Next example. So, at hagna dayon natin given ha. Ang N naton 21 moles. Ang pressure 78 atmospheres. Ang temperature 900 kelvins. Ang ginapangita volume. So, equation PV equals nRT. Volume ang gusto naton pabilin di. So, si pressure transpose. Volume now is equal to nRT over P. Okay. Tanan nga given, pamutang. 21 moles. Ang aton nga R, so sa aton nga pilian, laban-laban sini. You have liters. Gusto ko liters aton answer. Yeah, we will just stick with 0.082 for the meantime. And then L, atmosphere, moles, Kelvin. Okay. And temperature, 900 Kelvin. Okay. And then, ang P naton, 78 atmospheres. Okay. Cancel si moles, cancel si atmosphere, cancel si Kelvin. So, aton nga volume is 21 times 0.082 times 900 divided by 78. And that is 19.87. Yep, 19.87 liters. 19.87 liters. So, no specific nga unit ginapangita. So, let's stick with liters. Okay?